In this diagram, we can see elements of symmetry in cube, where we can see coordinates C1, C2, C3, C4, and C5, C6, C7, C8. Similarly, we can see your faces F1, F2, F3, F4, F5, and edges E1, E2, E3, E4, E5, E6, E7, E8, E9, E10, E11, E12. So basically, mean to say is, in this diagram, if you observe carefully, you have 8 corners, you have 6 faces, and edges. Total edge centers are 12 edge centers. So I'm just highlighting corners first. Just look at this: C1, C2, C4, C5, C6, C7, C8. Numbers are 8. Now I'm highlighting the next thing. So let us say we are highlighting next time with the edges E1, E2, E3, E4, and E5 down, E6, E7, E8, and then remaining 4 edges E9, 10, 11, and 12. Alright, so put together it becomes 12 members, edge centers, and we have total 12 edges also in cube. So centers also will be, each edge will have one center. Now see the next thing, faces. So we're now highlighting face centers. Where are face centers in the structure? F1, F2, F3, F4, F5, and F6. So as you can observe, these face centers which are highlighted here are total 6 in numbers. Put together, if you have everything added, it will become 26. And still we are missing one point. If you observe the whole structure, there are total 27 things highlighted, 9 in a row. So 9 in one plane, 9 in one plane, 9 in one plane. What is this one which is missing? That is the green one in the center of the whole structure. You look at the green one I have highlighted here. That's missing. Now if you add that also, it's called body center. Total becomes 27. So put together we have 27 things in this diagram. Let's take a fresh diagram. And in this fresh diagram, let us talk about what exactly is going to be discussed now, which is we are going to discuss here as element of symmetry. So if we again reconstruct the whole thing, that the number of yellow color things are corner, gray color things are edge centers, the blue color things which I'm highlighting now are face centers, and the green color one is body center or center of body. So if you count all those numbers put together, it will come 27, which is expected also. So I hope that should be okay. Now let us see, if we add all these numbers, it should come down to 27. Perfect. So it comes 27. Now let us understand what are different symmetry elements possible in this structure. Around body center, which is also center of symmetry. Why it is center of symmetry? The reason is the whole structure is symmetrical about this. The complete structure is symmetrical about this, and that's why it's center of symmetry. Alright. Now let's take the next diagram and understand if we connect opposite edges. So look at the diagram. Let's say we are connecting E1 with E7. So just check E1 and see the position of E7. Try to connect them. Okay. So when you connect E1 with E7, mainly you are connecting these edge centers. And once we connect these edge centers, what will happen? You get again one axis of symmetry around this whole cube is symmetrical. How many such pairs we can draw? So we can say there are total 12 edges, or we have total 6 pairs. So definitely we can do it 6 times. We can connect E1 with E7, like that we can connect E2 with E8, we can connect E3 with E9, etc, etc. 6 such pairs we can draw. Now come to the next part. After connecting them like with edges, what else we can draw? So we can see the same thing with like simple plane axis, which is like x-axis, y-axis, and z-axis. So just see the diagram next time. Connecting x-axis, y-axis, and z-axis. So this will be total 3 more axes added to this. Now what you can do next is you can connect similarly the diagonal axis of symmetry also. So we have 3 axes of symmetry which are x, y, z. Now we can connect diagonals. Diagonals, basically, if you see the cube, I'm connecting this opposite corners. Opposite corners, they're basically diagonals passing through body center. How many such body centers we can diagonals we can draw? We can draw 4 such members. 4 such members we can draw. So 4 plus 3, 7. We can write 4 axes of symmetry which are passing through diagonals. Passing through diagonals. Okay, so I'm just highlighting those things. 4 members. 4 plus 3. Total would be 7 here. And these are all axes of symmetry. Now likewise we can discuss a different plane of symmetry found in the structure, which are, we can take xy plane, yz and zx plane, so we can have 3 planes also. So let's complete first diagonal axis of symmetry. 4 diagonals which are giving us axis of symmetry. Now see the structure once again. Let's take simple planes, xy plane, yz plane and zx plane. Yeah, so I'm just taking this particular plane. Let's call it, let's say it is xy plane. Perpendicular plane can be yz plane, and one more plane can exist, which is zx plane. The third one could be zx plane. Yes. So put together, all 3 plane of symmetries can also be considered as element of symmetry in this consideration. Now the next important thing is, we can take opposite edges and then make a plane out of it. So just see the diagram here. I'm taking this edge and the other opposite edge and connecting them. So how many such planes we can think of? So this is one plane. Can I say in this plane what all will be there? 2 corners top, 1 edge center, 2 corners down, 1 edge center, and the body center will also lie in this plane. Then 2 face centers are lying. 6 such planes we can draw. 6 such planes. Why 6 such planes we can draw? Because we have total 6 such pairs which we can construct. So if you go back and just see, so we now have center of symmetry. Center of symmetry is 1. Then we had 3 axes of symmetry. 3 axes of symmetry. Then we have 4 diagonal axes of symmetry. So I'm just compiling the whole detail. 3 axes of symmetry, 4 diagonal axes of symmetry. So 4 plus 3 plus 1, this make 8. Then we connected opposite edges and we have 6 such pairs. That's also axis of symmetry. 6 such pairs. And then we had plane of symmetry. So if we count plane of symmetry, let me write first axis of symmetry through edges. It is 6 in numbers. So this whole summation is how much? 6 plus 4 plus 3 plus 1 is 14. So 14 members are because of axis of symmetry or center of symmetry. And then we have 9 more. So one is plane of symmetry. Plane of symmetry because of x, y, y, z, z, x. And the other one is diagonally opposite planes we connected through edges. That is 6 more coming up. So total 9 will be there in that case. If you put everything together, we eventually have what? We eventually have total 14 plus 9, 23 element of symmetry. I hope you understood the whole video. It's regarding element of symmetry inside cube. Please like, subscribe and share, and tell your friends also regarding this. Thank you very much for liking the videos. Thank you.